All right, good afternoon, everyone. I'm Julie Mock. I'm the Regional Sustainability Coordinator for Chaffee County. I think you all have been to these workshops before, but I'm happy to welcome you to our 7th of 12 energy code workshops that we're hosting this summer. The county got a grant from the Colorado Energy Office to help put these on, so we're thankful for them and excited to have you all here with us today. I've got a couple of just quick housekeeping things. Upcoming dates, August 24th will be our next event on lighting controls. That'll be here at the fairgrounds again, and we'll have a contractor presenting live that day. August 25th, we are hosting a heat pump training. Madeline with our team has been helping put that together. That'll also be here at the fairgrounds. It's an all-day training. There's a flyer on the counter if you want more information. It is limited to 10 participants. So if you're interested, I would recommend signing up quickly. It's free, and we'll give you more information on heat pump installation. And then September 23rd, we'll have another workshop on thermal management. So just keep an eye on your email for those future dates. Also wanted to let you know we have a survey out right now. It was linked in the email that was kind of a reminder for this event. If you have 30 seconds to jump in there and give us a little feedback on how these workshops have been for you, that would help us out a ton. But I think without further ado, we're going to kick it off. I'm going to really quickly hand it over to Margot to talk a little bit about blower door project, and then we'll welcome our guys from 475 Building Supply to present today. Thanks. And Margot, let me give you this real quick. There you go.
All right. Hey, everybody. I'm Margot Rode, and I'm along with Johnny Rosvani on the board of the Colorado Green Building Guild. And we were fortunate to have a gentleman in Denver who used to be a HERS rater and an architect retiring and donated his blower door equipment to CGBG, and especially for use here in Chaffee County because we're all still, a lot of folks are still learning on it. So we are coming up with a program that will lend out the equipment and give you links on how to use it. It's perfect. It's not, of course, to make up for the third party at the end of the project, but at least say post drywall, you can do a pre-test on your house and seal things up before things get too far along. So anyways, we don't have all the details worked out in terms of right now. I'm keeping it up in Buena Vista with me, but if you're interested in this, if you wouldn't mind putting your name and email, and we'll get a list going, and probably by the end of the year, we'll have something set up with Sustainable Chaffee where people can access how to procure the equipment. So thank you.
Just pin that in there.
Alrighty. Hello, everybody. Thank you guys for having me today. My name is Ben Olander. I am with 475 High Performance Building Supply, and today we are going to present our short presentation, Air Tightness is a Team Sport. A little bit about me. My name is Ben. I'm from the East Coast, originally from New Jersey. I've been in Colorado for about 4 years now, and since I've been with 475, have covered the Midwest and the Rockies, and now more recently just the Rockies. So I get to travel a lot less, which is good. Covering 17 states was a lot. So happy to be closer to home in the Rockies now. At our core, we are an e-commerce company. People know us best for our website. We have lots of resources. This is kind of a one-stop shop to get building materials, download resources, installation videos, blog posts, and kind of all of the above. Really where our good starting place is. We are most known for our free to download ebook details, actually. This is the little handout you guys all have in front of you. These are CAD and PDF download details that go through the different assemblies, walls, roofs, floors, windows, doors, covering 7 different assembly types. Most notably our historic masonry, wood frame, and then 2x6 and double stud assemblies. These have a lot of free downloadable details you could drop into your plans and use on projects. In terms of suite of materials, we have a little bit of everything. At our core, we serve air sealing and vapor control materials for builders and architects. So we'll have things for the interior, exterior, roof, windows, subslab, kind of grade to ridge of your roof. We will have some sort of air sealing or vapor control solution for your project. The one you guys have in front of you is our Hero 3000. I call this kind of our flagship solution. It's our vapor permeable peel and stick. This is great because it can be used for walls and roofs in both locations continuously. We'll get into this a bit later, but this is the sample you guys have in front of you and what we'll be kind of playing with today during the hands-on portion of things. Additionally, we have some more interesting materials. This is a liquid applied product called Viscon. It's airtight, watertight, and vapor variable as well. This is great for flexible scenarios where you have varying substrates and challenging conditions, and this is going to create a flexible air seal without trapping moisture in the building actually. So very different from that of some of these Prosecco's and some of these other liquid applieds on the market. Additionally, we also carry ERVs and HRVs through the Brink and Luno systems. This will be most comparable to Zender, as many of you may know. That's kind of the biggest player in the market right now for ERVs. And then we have a smaller solution called Lunos, which is very interesting for retrofits. It's a decentralized solution where there are 2 fans that go in your walls in 2 locations at minimum, and they take turns pushing and pulling to create ventilation within the home. So great for projects where you don't want to run ducting, but still have ventilation requirements.
That's not energy recovery.
This is heat recovery. Yeah, so yeah, HRV, not ERV. So at the back of this, there's actually this ceramic heat core. We now have a polymer one, but essentially on the exhaust stroke, this will heat this core up to ambient temperature, and then on the supply, it'll bring it back through, bringing it up to the interior temp. Our unit currently has around, I think, 91% efficiency for heat recovery. So pretty good for how big they are. And they're also very low energy. They're DC power, so like a AA battery could run these units. They're marketed as set it and forget it, 6 inches in diameter. And they go for wall widths 8 to 20. And then this is a newer product offering to our suite of solutions. It's a fantastic product called Smart Rock. This is actually a collaboration with Proclima, the brand that we represent, and then Rockwool. And this is Rockwool's cavity rock boards with Intello Plus, our interior smart vapor retarder and air barrier, which we'll talk about a little bit further. That membrane adhered to the face of this. So in one install step, you pin up the boards, tape the seams, and then your R value and your air sealing and vapor control is more or less done in one step. This was created for masonry construction. We are seeing this pop up in between double stud walls for continuous insulation. But in our climate, I'm mostly seeing this in crawl spaces and basements. Not a ton above grade because our types of builds don't require this type of stuff. And then we have a full suite of daylighting solutions through Facro and Lamilux. The Facro will be more residential. Lamilux will be more kind of commercial, larger project, institutional buildings just because of the size and price of some of these units. But all in all, as you see, we kind of encompass a little bit of everything when it comes to the project. So we are somewhat of a one-stop shop for high-performance construction. So now I just want to take a quick pause. I'm going to do a quick little demo to kind of stress the point of pressurizing your tape. So I'm going to take 2 pieces of tape here. We have our Tescon Vanna, which is our airtight, watertight, and vapor permeable air sealing tape. This can be used on varying substrates, wood, metal, PVC. It really only struggles with rough concrete. So it's good for kind of everywhere as your air sealing solution. But what we want to stress is that these are pressure sensitive adhesives. So all of our tapes and our peel and stick membranes require you pressurize them. This is a tool called the Press Fix. It's like a squeegee, soft edge, nothing innately special about it. But what it does is create even pressure. And what I want to stress with this is using your hand is not enough. If I had a piece of plexiglass, you'd be able to see under it. But what I'm going to do here is make a little fold tab for myself. Stick this on. I'm going to pressurize one of them with the Press Fix. And then I'm going to do one with my hand, and then in an hour we'll pull on them and you'll see which one pulls off and which one's got real much better adhesion. This is a fun little trick to get the tape unstuck. You can roll your finger down the top of it. Do another fold. Great. All right, put this aside. We'll come back to that. Just make a note. This was our Press Fix. This was our non-Press Fix. Just so I don't forget. All right. All right, so air tightness really is for everyone, regardless of the size of your project, big or small. Believe it or not, both of these projects had the same air sealing strategies employed on both of them. This is a project, this is the Cornell Tower, I believe, right? Yep, this is in New York, and these had passive house panels, or panels wrapped with our membranes on them, craned into place. So this is a very large, high-performing passive house. And then on the right, we have a tiny home. But what's interesting is that these two buildings employed the same exact strategies regardless of scale. And we'll get into what some of those strategies are. So why should you focus on air tightness? Well, primarily from an energy perspective, this is going to be the biggest factor in a home's heating and cooling demand. For the comfort of the occupant, we want to obviously eliminate drafts and have consistent temperature within the home where you don't have cold spots in certain areas. For the health and safety, as you guys currently are experiencing in the mountains here with all the smoke in the air, the more airtight your home is, the less smoke you have coming into your home, so you maintain healthy breathing air in your home. And then the bottom line, the less drafts you have, the more energy savings overall you have. You're not paying to put your warm air through your windows out the front door. So why isn't this really common practice in many jurisdictions? Well, older code has not really stressed air tightness in the past. I know this is very kind of applicable to this jurisdiction as I think you guys are abiding by IECC 2021, correct? And that's 3 air changes per hour. That's somewhat arbitrary. It doesn't really mean much. It's a step forward from older code, which was like 5 ACH, but that starting number of 5 was not based in any testing. They just had to pick a number to start with, more or less. So the 3 is an improvement, but it's definitely a bit on the lower end of what we're pushing for. We want to be blowing past code. We don't want to be building to code always for some of these factors. So measuring air tightness. Who here has been part of a blower door test before? Show of hands. Okay, good amount of you guys. Well, this is how we're actually verifying the performance of these materials on projects as we kind of tighten up the home in different stages through putting up the sheathing, the house wrap, the windows, the insulation. We want to be testing through each of these stages to find air leaks and seal them up before they get concealed in the wall. We're testing in two main measurement options. It's the surface area leakage, which is the best way to put it is if you took all of the holes in a house and added them up together, how big would that one hole be in terms of air loss? And then the volumetric leakage, this is what we mostly rely on, and this is air changes per hour, or how many times in an hour is all the air in the house being recycled with outdoor air and then back again. So lower air changes, less smoke in your house, essentially. But this is a cool model we're going to look at. So we're going to do a quick study or a model. We're going to model a house, and all that we're going to really change in the model is the air tightness. Everything else about the house will keep the same. Orientation, insulation, windows, HVAC, all of that will stay constant. All we will change is the air tightness. So starting with old code, which is kind of unverified, doesn't have much basis in why it's 5 ACH, for example. Old code, you can see, is very energy demanding, close to 12,000 kilobTUs per year or per square foot per year, so very costly. These are the old leaky homes that we kind of have existing in a large stock of in the housing market. Moving towards newer code, the code that you guys are exhibiting, you can see as you start to make the home a bit more airtight, you'll get immediate savings. And then moving towards what ultimately is passive house levels of efficiency of 0.6 air changes per hour at 50 pascals of pressure, you can see just the incredible amount of energy savings you get, and that's simply from air changing values alone. So just air sealing the home a bit more. This is very interesting, but many people don't know this actually. But the R value of an insulation is gathered in a lab environment where they're air sealing the insulation on all 6 sides. So it's in a lab, airtight box. But on site, we're not necessarily matching those conditions. So if you are not air sealing your exterior of your wall and the interior and the transitions from roof and to floor and encapsulating that insulation on all 6 sides, you can start to get a reduction in that effective R value. You cannot reasonably expect the same performance as given on the manufacturer's label unless you're meeting their conditions. So air sealing is important, and this kind of comes into effect with this study talking about wind washing, that if you're not using an airtight house wrap, something like many staple applies we know is like a Tyvek, as that's flopping in the wind, you'll actually get up to a 90% reduction in R value. So on old leaky homes, I don't know if in the wintertime, if you've ever been in one of these older homes, but as you've walked towards a wall, you'll probably feel the cold before you even get to the wall. That's your R value being sucked out of the wall from wind washing, because your exterior is not stopping that wind movement up inside your siding and in your insulation level, insulation areas. So I wanted to ask the room, when does everyone think air tightness usually happens on a project? If you had to pick a phase, anyone? That is usually when it happens. That is the correct answer. It usually happens here. This is why it's the big arrow. Kind of all happens at this one stage, where before that, you're not thinking about it. It has to happen here, and once that's done, there's not much more thought process towards the air sealing aspect. What we want is it to happen a little bit everywhere, kind of as you go through the process. We don't want it to be a one good push, because then there's a large factor that you could miss something. And then once you get your finish up, that is what it is, and you're not going to be able to really remediate that unless you're going to rely on like aero barriers and kind of cover all solutions that are extra spending. Honestly, it could be avoided. So how do we get there? Well, primarily the red line test. How many of you are familiar with what the red line test is within an enclosure? Okay, well, essentially what it is, it's a air tightness test where you take an elevation view of a plan, and you should be able to put your pencil down and draw a continuous red line through all surfaces at the exterior of the home. And anywhere where you have to pick up your pencil is essentially where you'll find a hard transition in the building. So typically the corners, the floor transitions, the windows, the connection to roof, if you have an attic. These are areas where if you don't have a plan and you got to pick up your pencil, that's something you'll want to zoom in on and kind of think about how to sequence this to get around this type of detail. Additionally, through good site management, we've kind of coined the term air boss on all of these newer projects where air tightness is a requirement, certainly as code is now pushing it. We want you guys to denote one person on site, whether that's the GC or just an individual that you're telling them that's their job, to be the air boss. And their simple job is to walk around the job site as trades are installing things and working throughout their day to point out when there's been an air leak or an issue where they might have punctured a membrane or ripped the house wrap and they're not making a note of it. It's not the subcontractor's job to necessarily make a note of that and pass that to the GC to fix it, because that's going to get missed. They want to do their job and get out of there. More likely, having someone to actually, look around and find these locations, flag them out, make a list, and make sure before the next day or the next week they're getting taken care of. It's a more iterative process and helps people keep kind of up with the air sealing, so it's not requiring one big push, but it's feeling gradual. And then lastly, through verification and testing, the materials we sell and kind of the methodology we're pushing is an airtight enclosure. And the best way to test that is to do a blower door test on your house, positively and negatively pressurize your home to find air leaks coming in and air pushing out. Using smoke pens is very helpful, but this is the best way to physically verify the air sealing you're doing. And especially if you do it in stages, for example, if you do a blower door test after you do house wrap and then put windows in and seal them up, you should see drops as you go. It should be improving throughout the process. And then obviously when you get to installation, it might get worse before it gets better again. But this is the best way to verify progress, especially as you are supposed to be hitting these new values. Here's the red line test, as we're all familiar with. Air boss, kind of went through them. And the air boss, this is a kind of a pre-construction checklist that an air boss might have on site to kind of go through every day and hit these line items to make sure they're being done. So they'll do a walk and just, check that the mock-up has everything done. When they're pouring foundations, doing a walk, that those connections are kind of ready to go. But it's just having someone keep a more focused eye towards the air sealing aspect of a project, and not just having it being figured out throughout the stages. So ultimately, the path to success with having intentional air sealing is getting things kind of dialed in early in the design phase. So that's thinking ahead in the plans, working with the architect, maybe an envelope consultant, to help nail down how some of these transitions may actually happen on site in practice. The architect can draw them all day, but as you guys know very much so, on-site conditions don't always mimic what is shown on plans. Plans are 2D, buildings are 3D. So there's a lot of conversation that has to be had back and forth to make sure we're all on the same page of how we're pulling off some of these transitions. The one I hone in on the most is the kind of floor to floor transition is something that, if forgotten about, creates a lot of excess work, essentially, as you have to go up between joist pockets with membrane or liquid applied or a foam, for example. And that's a lot of remediation that you can avoid by pre-sequencing and wrapping the rim joist. And we'll get into what that actually means and looks like. But just to get your gears turning, that you want to be thinking about these things before the construction process has actually begun. Have a game plan to move forward. Secondly, we want to choose materials and proper air sealing methods. Again, site management, choosing an air boss to stay on top of your goal, so you can hit that and not have to pay for remediation and extra labor in that process. And then verifying often. At 475, I mean, we're not as local to you guys, unfortunately, but we do have a blower door, and I am going to local job sites to help verify and help them give a peace of mind that the materials are working as intended, and help them find leaks and just help out a bit. So having one is nifty, but it really is invaluable towards any project, regardless of what air tightness level you're trying to hit, to verify the air seal. I mean, from a perspective of drafts alone, if you can eliminate just moving air, it'll be a more comfortable space. So airtight materials. Well, what do you guys think are some common airtight materials, or what are you guys relying on mostly for creating an air seal on a home? Anyone? There you go. That is typically what we're seeing. Well, most airtight materials come in rolls, buckets, and sheets. You guys will know zip, obviously foam. Within our suite of materials, we offer Adhero, which is the peel and stick you have in front of you. There's obviously Blueskin. We have mechanically fastened membranes with Demento. That's similar to a Siga membrane, or like a Tyvek, a staple applied membrane that's tape seams. And then obviously we have the fluid applied with Prosoco and the Viscon, which I have here, which we'll show you a bit more of. But we want to be using materials that are manufactured to be airtight. Drywall can be airtight when it's brand new, but over time it'll break down and crack, and you'll get air leaks. Obviously, as you see, you could put a hole through it pretty easily. So not a very robust material to be relying on for an air seal. Additionally, grout is not airtight. Concrete, poured concrete is, but the grout connections between CMU blocks is not. This is actually showing a blower door test where they depressurized the home, so they pushed all the air out, and this was air pulling in through the grout connections and puffing up this plastic bag. OSB, again, is not manufactured to be airtight. It can be made airtight, same thing with plywood, but we want to be using materials with the intention in mind that they serve the purpose that they're manufactured to serve. You can obviously turn some of these materials into more airtight and resilient surfaces, but it's much easier to use stuff that are manufactured to be used in that way. So we asked this question, but you guys are using a lot of, spray foam is very common in the industry currently. But at 475, we don't love spray foam. I mean, it is in a lab environment a silver bullet, but on a job site, it doesn't quite function as such. I mean, it's chemistry, and chemistry is done best in a lab, not on a job site. So you get inconsistencies with spray foam, as you guys have probably seen on many job sites. This was a project in the Front Range area. It was a retrofit. They pulled down the wall, and the foam actually fell out of the wall when the drywall came down. It cracked, it dried, it failed, and you could see it probably hasn't been working here for a very long time. Additionally, foam shrinks, or I guess foam doesn't shrink as much, but foam is very rigid. Buildings move. So new construction, you'll get swelling and shrinking of the framing over time. Well, your spray foam that was initially installed direct stud to stud, once that framing begins to swell and shrink, it'll pull away from the foam, and the foam won't move with the building. And then you could get gaps opening up, which will create air leaks, and air is very wet. You'll be introducing moisture, and then eventually you can have issues. It's not to say every install will do this, but it is a factor of foam that is true, its rigidity. And then lastly, foam boards do have shrinkage when exposed to some UV. Here's a study from Joe Lestibrick with Building Science Corporation that kind of gets into the nitty-gritty of foam shrinkage on projects and how you can avoid the use of such. In general, we are trying to air seal on both sides of the projects. I know that many projects out there, if not most on the market currently, are locating their air barrier at the exterior sheathing. That's why Zip has a product. They're locating the air barrier at the outside. Our intention is that we want to be air sealing on both sides of the wall. But why do we want to do that? Well, there's two layers of air defense. even though you might be calling out your exterior house wrap and airtight material, we want to be creating our air barrier on the inside to keep the conditioned air in the conditioned space away from the cold sheathing. That's the main goal. But inboard is ultimately better. The image on the right is showing our interior air barrier Intello Plus. It's also a smart vapor retarder. But the reason we're keeping this on the inside is because it keeps the conditioned air within the conditioned space. Leaks can often be found more readily and easier to repair. And your air control layer should also be your vapor control layer. So you'll see why this is important. But in a normal winter condition, you're creating a lot of heat. That heat is driving through your walls, trying to get to that cold sheathing and ultimately get outside. If that sheathing is in fact cold, you could get condensation on the back of it. That'll drip down your wall and eventually rot out your bottom plate or your mud sill. And we're trying to avoid this. So by putting your air barrier behind your drywall, inboard of your insulation, you're not allowing that warm, moisture-laden air to reach the cold sheathing. You're not going to create a condition anymore where you'll get condensation. The warm air is kept in the conditioned space where you want it with the occupants. This is a great study we're going to talk about quickly. So this is following the movement of water vapor over a single heating season, a winter in Chicago. And this is showing how much water diffuses through a single sheet of drywall without any holes in it. So brand new sheet of drywall, you'll get 2/3 quart of water diffusing through that wall over winter. Not a ton. But you now take a piece of drywall and add a 1-inch by 1-inch hole or a few cracks throughout the building. It'll add up to that size. And you'll actually get up to 95 quarts of water. In simple terms, 5 office gallon jugs. So imagine walking the perimeter of your house with 5 of these and just pouring them out and walking the perimeter until they're all empty. That's what's happening in your insulation, on the backside of your sheathing, and ultimately in your walls if you're not air sealing as much as you should be. And this is why we want to keep the air barrier to the interior, to keep this moisture that's in the air away from condensing surfaces. But as you can see, there's many different sources of moisture. The size of the droplet is very directly correlated to the source of moisture. So air infiltration being our biggest source, air is just very wet. The air carries the moisture. So by having an air leak, you're going to carry a lot of moisture with it, kind of as you saw in that prior study. 1-inch by 1-inch hole, you've exponentially increased the amount of water in your walls. So can't understate enough that air is very wet. Capillary action will be up there as well, wet construction. This is why we also want to have capillary breaks at the top of our stem walls and we're pouring concrete. Even though we might be using pressure treated mud sills and bottom plates, that's not always enough, not always enough over time to stop that capillary action from pulling into the framing. Wet construction, obviously, as we get rain and things are exposed. And then the smallest source of moisture is actually through diffusion, through materials absorbing moisture and then re-emitting them to the other side. That's going to be our smallest source. And this is a very interesting image. So what this is trying to show is a project before and after a retrofit. On the left side, you can see through a thermal imaging camera, the building's red hot. This building is getting baked dry. This is how all of our older homes currently exist. All of the heat is making it to the exterior wall, baking the moisture out of the wall. Older homes were leaky, but they were not very moldy. And that is because they were so leaky, actually. The heat is free to move where it wants to, effectively making it to the outside, and any moisture that's behind your exterior wall will get baked dry. Well, as we are insulating more with newer code, you're no longer able to bake your walls dry because you've now kept the heat where you want to in the conditioned space. So the image on the right has now been insulated, and you can see the windows are the weakest point, which you'd expect in most projects. But now they can't dry through baking their walls dry. They have to dry through diffusion. They have to have materials that allow moisture to pass through them so it can safely dry out. This is why we push against the use of foam, because as we insulate more, especially with foam, that warm air is not going to bake the walls dry and bake the moisture out of the foam. And the foam is vapor retarding. So when moisture gets in the wall, which it will, because everything gets wet, we just want to make sure we're designing our buildings to dry more than they are wetting. So when moisture gets in behind your foam, it's not going to have as easy a path out as it had in. And it's going to fester in there and accumulate, and you could eventually get mold and rot. So this is just kind of showing the smart vapor control. So the Intello Plus, that image I showed you guys earlier, the white membrane on the inside, the way it would work in an ideal condition is we want our smart vapor retarding membranes to open and close. And that's what makes them a smart vapor retarder or vapor variable. It's permeability, it's drying potential, will actually change depending on the relative humidity to both sides of the wall. So starting on the left, in a wintertime condition, your Intello, your interior smart vapor barrier, you would want it to be vapor closed at 0.13 perms, essentially, keeping all that moisture inside the house where you want it, not getting into your cold sheathing, hitting your walls, and condensing. In the summertime, when the vapor drive is flipped, it's in most climates more humid outside and cooler and drier inside. That vapor is trying to drive in through your exterior walls, which it will find a way in. And then it opens up to allow drying continuously to the interior. So effectively, we're trying to use materials that don't stop the flow of moisture when it does not want to be stopped. I know this was a condensed presentation. We covered a good amount. I want to open up the questions. But ultimately, the plan to success is planning ahead, choosing the right materials, denoting an air boss or someone on site to keep up with the process, sequence for continuity for continuous connections, and then testing early and often in the process to verify the progress as you go. And why do we want to be airtight again? For energy efficiency, comfort of the occupant, health and safety of the occupant, and then the bottom line, energy savings and ultimately money savings. So we'll dive into the hands-on, which we'll get into some of these transitions and what they look like on a job site. But I want to hear from you guys of what you're really seeing, what challenges you have, what you're currently having to do to air seal, and kind of start the discussion before we jump into the hands-on side of things. Thank you. Anyone have any questions about anything before we jump into the hands-on?
When you're air sealing the inside of your walls and ceilings, do you have to fur those out, or what happens where you have electrical penetration?
So you don't have to fur them out. It would definitely make your life easier to fur them out. There's kind of two schools of thought. You either pre-sequence with a service cavity to kind of bump your utilities off your air barrier, or you use lots of gaskets to seal in line with your air barrier. This here I brought is something called a Lesco box. This is an airtight utility box. So you take your double gang box and it would mount and nest within this box. So then you're going to poke two holes or one, run your wire through this box. And then when this is installed up to your Intello and your stud, it'll be flush with the face of your wall and your actual outlet will be bumped out into this nook. But what makes this easier is that your air seal is located at the penetration at the box. You don't have to spray foam or a liquid into the actual utility box itself, which makes the electrician crazy and makes everyone's life harder if they have to remediate. So your air seal is a simple tape connection. Your wires poke through, tape them off. You're now air sealed in the box. Anything else you do in here, we don't care about.
And that's what you use for forceware? Like literally it would be that big to put 4x4 box in it?
Correct. And these are cut and kind of origami. They're soft. They have a seam in them with the intention that you can cut it and widen it with a piece of our air sealing tape to kind of fit the size you need. We're not saying you have to use the Lesco boxes. We have many examples of people making their own with plywood and taping the seams of their plywood boxes, depending on where you're jamming utilities. If you have 5 switches stacked next to a wall, obviously this might not be optimal, but to understand the purpose of it, to implement the same strategy with your own materials.
That goes on prior to the
It could go on either or. So in process, I'm usually seeing, because of when insulation and this air barrier is being run, electrical's happening first, obviously. So I'm seeing these handed off to the electrician and the GC, usually telling them to not worry about the air sealing side of things. Somebody else will come back and do that because that's not their job, obviously. But just give them a stack of these. They come in 30 packs and individual. They're pretty affordable. And then all they have to do is when they pin these to their stud, this will be the side going to the stud. They'll pin this to their stud, poke their holes, run their wire through, and then install their box and then walk off the job site. Somebody else, maybe insulation, will come back and actually pinch tape the 2 wires to get the air seal and face tape it off to the Intello. But these can be pre-placed everywhere. As long as your box is nested within this, you're kind of good to go going forward. Because remediating backwards with this when your outlets are
one size fits all.
Correct. One size fits all. And then we have people cut these and join them together to make more, bigger. But this is what kind of amongst the suite of materials that we offer, along with nice gaskets. These are tape embedded gaskets for wires as well. We have these all the way up to, I believe, 8 inches for our largest, being for some, ERV or HRV ducting. These are just EPDM. Our tape sticks this. It will stick to our membrane. So this is a kind of a flexible, pressure tight air seal. with the idea that if you install this with a wire penetrating through it and you need more wire, just pull more wire through. It's a pressure fit. You don't have an adhesive locking it in place at that plane. So you can pull more through. And the idea with all these materials is that we want to be air sealing, but creating conditions where if there's remediations over time, you want people to live in this house for 100+ years, generations. So
that would stick to your
correct.
Stick to your Nutella?
Yep. Yeah. This is correct. This is going to be the same tape of our Tescon Vanitape. It's just the EPDM gasket embedded within the layer of tape. So our larger ones, we could technically make that, but it's easier to just tape the 4 sides than waste all the tape on the center here. Yeah. So we've got flexible gaskets to make some of these kind of connections easier. And then the last thing I wanted to jump on before we kind of start with the hands-on things is the liquid applied. This is going to be a great material, not only for your market, but anyone that's currently spraying spray foam or air sealing in general. This is a product called the Aero Fix. And what it is, this is essentially a airless sprayer for sausages. So you'll take your Viscon sausage, which is your liquid applied. We have 2 versions, a standard and a fibrous version. The standard version can fill gaps up to 1/8 of an inch. The fibers can do 3/4 of an inch. So you got some flexibility between substrates and the conditions you have to cover. But what's nice about this is that with one tool while on a ladder, just by twisting this nozzle, you could go from caulk line to spray. So if you're in a rim joist where you have an existing kind of floor transition and you have to air seal that pocket, really annoying to get a caulk, go up there, get down, get something else, paint it on. Much easier to be on a ladder, spray the pocket, switch to caulk the seams, move to the next bay. So this, yes, yep. And what's great about the material is that it changes colors as it's kind of curing. So it goes on black, dries to blue, or sorry, vice versa. It goes on blue, dries to black, so you know the cure time and when the surface is dry and ready to stick to. I'm seeing a lot of this in really any project that has air sealing goals. This is a flexible solution that's non-foam. It's water-based, low VOC, non-toxic. You don't need any respirators to spray it. If you get it in your eye or on your hands, just wash it with warm water. It is an acrylic-based adhesive. So similar to an acrylic paint that, or latex paint that when it dries, it will peel off if it's not fully cured. But it's a very adaptable material. And what's great about it is that it's vapor variable. So similar to that last image of the 0.13 perm to 13, this will open and close depending on the moisture content. So you won't create a condition where you're trapping moisture ever in the wall. And I'm actually selling a lot of this to spray foam installers. That condition I showed where the studs separated from the foam, this is what Viscon's great for. If we can't convince you to not spray foam, spray this on top of your foam, because then you won't have that gap opening up between those 2 surfaces. And I want to quickly show you, because I do have a sample of just how stretchy this stuff is. I cannot stress it enough. But I've got one right here, my bag of goodies. Here we go. So we've got our Viscon. This is our Viscon regular. You can see how smooth it is. This is just on a piece of paper. So it wouldn't look like that. It would follow your substrate a bit better. But if I could get some off, what I want to show is this will move more than your building should ever move unless there's an earthquake. So I could just keep going with it. But you see what I'm trying to allude to here is that this is a flexible solution that will not cause moisture issues, that can do the same junctures where your foam is covering, but you'll still want to insulate if you're not going to be using foam. But this allows you to put permeable materials, a bat of insulation, inboard of it, where we're not worried about trapping of moisture and having to deal with those types of issues. But before I get any further, the last thing I want to show you guys is 2 things, and I'll pass this around. This is our flagship tape, my favorite. It's called Contiga Solido IQ. This is our concrete tape. This can stick to concrete without a primer. We'll stick a fresh piece on, but I wanted to show you just how strong it is. This is a cinder block, and you can see, I'll pass it around, give it a tug. You can see the adhesion. This is great for many connections, but I'm seeing a lot of it at base of wall for sheathing the foundation. Because it's primerless, it can stick to the substrate very well and becomes very strongly bonded. We have a version of this also. It's a double-sided tape for windows, but I think this will be a good opportunity now to start the hands-on and kind of chat as you guys are working through some of these things. So I'll pass this around if everyone wants to feel it and give it a tug, but that is the tape. Contiga Solido IQ. And I have samples of all of these things, so I can give you the samples for the individual tapes that you would like. But yeah, let's start the hands-on side. I think we're gonna 1, 2, 3, 4, 5, 6, 7. We have more than enough. So
we can reorient however you guys want. Some of you guys can do your own, or you can team up. So we got 5 of these. But here, this is our first attempt with these new things. We wanted to have a travel edition. Our mock-ups, not to bring in a whole big wall.
yeah, traditionally I'm showing up with a wall on wheels, which is a bit harder to move with.
But we have knives on the table, and that'll be helpful. But,
Yeah.
We have basically a lot of different penetrations.
You can say what they're showing. Here we're showcasing a beam or a rafter. Here we're showing a wire penetration, a pipe penetration. We're going to be showing a window installation with a continuous tape at the exterior. Imagine this is a window, showing sealing over a gap. Additionally, we're showing sealing in tight spaces. If you forgot to pre-sequence and preset your air barrier before you ran your partition walls, for example, where you had to run a membrane behind that partition wall, we have a press fix. You could still get in there, but this is stressing that if you pre-planned, you wouldn't have to get in there in the first place. So, no problem. All right.
So feel free to.
No problem.
I want to show you one that is very helpful, and it comes up often, but that is a corner tape method, which if you have a little piece like this, you can fold it one way, fold it the other, and then I know where the center of that is. I cut from the center the short edge, and then this is your little corner there.
Johnny's showing you this taping technique. We do have a tape that is manufactured with the purpose of folding. It's the same exact tape as the Tescon Vanna. The only difference is the color and the backer. This has a triple release backing strip, so you can pull just one of them, nick that just corner, and fold it. It's a lot easier than working with the full adhesive backer. But to show you that both are possible, we do make one that makes it a lot easier. So this is great for interior corners where this thinnest release strip actually is the thickness of a piece of drywall. That's on purpose. So you can face tape to your interior window frame like that on the inside, and when you run your drywall finish or drywall return, it should cover that piece, that sliver, in one sheet. So it's purposely manufactured with these preset widths to make it easier for yourself. And we have wider ones if you're going to face tape, but yeah, these triple release orientations make some of these folding easier. Additionally, it's so you can pull one, get it into the corner without this folding and sticking to itself and grabbing onto everything else around it. So this is great for interior detailing. It's good for outside, inside, but I mostly see it for interior finish near the windows.
So none of these products are going to react with foam, like a foam form?
No, so yeah, so you can stick this to all of that stuff.
All of your products?
Correct. The only thing we have compatibility issues with is silicone. And that's across the construction industry. Nothing will stick to silicone but silicone. The backer of these papers is covered in silicone. So our stuff wouldn't stick to it too well if you encountered that on a window frame or, using a silicone caulk. That would cause an issue. You could put silicone on top of this stuff, but this won't stick to silicone. Aside from that, you can stick this to ICF foam boards, spray foam even it'll stick to. I won't recommend spraying spray foam onto this stuff. There's an exothermic reaction. It can melt through this. It is polypropylene based, so it's plastic essentially within some of the mixture. So don't spray foam onto this, but you can put this onto spray foam in terms of compatibility. But yeah, so let's start with some of these things. What I want to start with is the point penetration. You guys will be very familiar with this, as you know, with the pipe and the wire. I'm intentionally not giving you guys the gasket because I want to show you how to air seal without it, and to show you why the gasket makes it easier for you guys, essentially. But what we'll start with is the wire. So I want everyone is everyone in a group, I guess? 2, 1. Everyone's got something to work on? Perfect. So start with the wire. Yeah, so the simplest way to do it is pinch taping. And this is taking 2 pieces of tape and halfway up, joining them together around the wire, pinching off each side and then running it flat. So everyone can give it a go, and then I'll walk around, and if you guys have questions of how to best do it or whatnot, I'll answer them. Yeah. Yeah, and Johnny will have some other tips and tricks we can show you.
You'll see it's much easier to use this because I can have the sticky side pointed out, get it right in there, boom, like that.
And a good trick for the tapes, because pulling that adhesive is rather annoying. A good trick is to take the tape in your hand like this and cup it.
Sure. Oh, yeah.
Just cup it, and then if you just run your finger down the top of it, the adhesive will grab onto your finger. And then, so cupping it and just running it down is the easiest way to get the adhesive off.
Yeah. Watertight.
Oh yeah, that's a good point. That's another thing I wanted to show.
Oh, show them. Is there a Tupperware? Yeah, we're going to show you guys. All of these tapes are also non-water soluble, so they can actually be installed underwater.
Yeah.
Like Flex Seal almost, and it'll stick. So if you have wet conditions, it'll squeegee the water out from under it. Real neat stuff. Yeah, they had an ad of 2 scuba divers sticking this underwater to show it. Yeah, so that's like the simplest way to, more or less do the penetration. Obviously, it didn't take very long, but if you have a lot of them, it can make it easier to run a gasket over. Again, if you have to come back, you can't pull more through.
So this is a double wire, let's say going into that box.
And you'll see if we
panel.
let it sit for a second, try to pull it up, you can.
Just don't worry about the airtime in between them.
So yeah, so it depends where you're actually going to be air sealing. So if you're air sealing at the membrane, for example, so this is showing
This would be on the outside.
yeah, this is the exterior house wrap. So let's assume this is exterior. Have this be interior.
Water.
You would drill a hole, poke this through, and then do this same pinch tape to the base of the box.
So
anything within this.
A lot of times there'll be 2 wires together.
Correct.
Coming through.
Yeah, yeah.
So is that a no-no? Did
So-
they separate the wires before they come through?
Correct. Yeah, you want to treat every penetration as an individual
Oops, sorry.
air seal. You see it squeegee all the water out from behind it? Exactly. So now I want to quickly show you guys, because it's been a little bit, I'm going to give this tape a tug, and I want to just show you guys the difference in pressurizing it versus both. And I want to mention, both will be very sticky, but I'll be able to more easily remove one than the other. This is the one I did not pressurize. And I want you to watch this adhesive edge and look at how much of the adhesive grabs at it actually when I start to pull. It's a good amount. It's working. So the tape failed a little bit, but the adhesive still grabbed on. Well, if I use the pressurized one, you'll see it's much more adhesive.
You can see all those little strands.
That's it embedding into the physical surface, and I'm really cranking on this thing now. But there is a time delay engineered into the tape. So when you pressurize it, it'll start to actually adhere. You probably have about 30 minutes before it starts to do this.
Yeah, you can.
Before you're leaving residue. So within 5 minutes, you can stick it.
Right.
Sure, let's move it. We're not happy with how it's sitting.
Oh, I can pull it right back off. Oh, not.
But once you pressurize it, exactly. Yeah.
Yeah.
Then it becomes permanent, essentially.
Then come back in an hour, and then you'll just rip the whole thing apart.
Yeah. So in most scenarios, when we're doing this, we're using like OSB. The OSB will fail before the tape does. It'll just rip, which I'm sure you guys will probably see often. But yeah, that's like why we want to pressurize it, and that's physically showing you guys the actual adhesion into the substrate. And that is tenfold with our concrete one, as you would think, why I can pick up onto that block. And before we all leave, I'll just stick a fresh one and show you immediately I can pick the block up. It's like instant. Very strong stuff. So are we all happy with our wire penetration? Awesome. These look great. Any questions or issues with doing this process for the wires?
So this one we always like. Super simple, super quick, still flexible. But if you want to be able to pull the wire through, it is nice to have that gasket, which, like he was saying, this stays on just through pressure around it, and that stays airtight around it. I can pull through as much wire as I want. I can keep going. So for a typical single wire, this is fantastic, but I can't keep pulling it. That's your only downside.
Yeah.
There.
The intention with most of these things is we want to obviously be air sealing our homes a bit more, but we don't want to be doing it in a way that remediating, if we want to make a change on our homes, going to have catastrophic damage to all the work you've already done. So it's pre-planning, and this is the good question you had with the service cavity. Why we'd want a service cavity or a stud inboard of our air barrier is so then if we run new utilities in the future, we don't have to degrade the air barrier and penetrate it and worry about sealing it. It can all happen inboard of that, and you don't have to touch the air barrier then. So if you put a photo on one wall to the other, or move a TV, you don't have to have the thought process of what's going on behind my wall. Am I causing an air leak? The homeowner should not be thinking about those things. They should put their photo up and move on with their day. So it's on you guys to pre-plan to create these conditions where they can make a hole and put up a TV and not degrade the air barrier and performance of their home.
Just explain that to their pocket.
Exactly. Yeah, that's exactly. That's the better way to.
Oh, good.
Yeah. Yeah, no, that's the way to relate it for sure. So the next connection we'll go through, I actually think we'll do the one on the left showing kind of a double stacked stud or a sistered member very close to an exterior wall. So what we're showcasing here is why pre-sequencing is very important. So this is a condition where you can obviously get tape behind, and it's purposely set to the width where you can get a press fix in there. You can stick a tape in here, and we want you to. We want you to put a tape in there and press it down to show you guys that it's possible in tight spaces, but annoying. And you can kind of remediate and get away from some of these labor-intensive tasks like air sealing in all these tight corners if you just put the membrane there before you put your partition wall. Pre-sequencing, thinking about, I'm going to put partitions up, but I'm going to wrap a membrane, do the membrane on all the exterior walls first, then do your partitions. So you don't have to seal every top plate, every bottom plate. So, and we're aware that this is all happening in process. We're not trying to sway your existing sequencing of your building, but it's as simple as when you get to this exterior wall, put a piece of membrane there and then pin it up. Leave it, forget about it. When you come back to it, you could just tape off to either side and you've now gone behind that section of wall without having to cut or get, this in there, and it's a lot of labor. So this will reduce a lot of that.
Fasten that to the back of my wall.
Yes.
My partition.
Sure. Yep. Correct. Either or.
I want to be able to open that up to put insulation in, right?
Exactly. Yeah. So you could do it to the back of your partition and just leave it flapped.
Staple it.
Yeah.
So this is another good example. This is between floors, like he was mentioning. So the process of going around every joist, total pain in the ass, so much labor. But if you get this on there first, and this is kind of part of the reason we always suggest an air boss, because everybody else can just go about their business.
Mm-hmm.
And then if somebody's there at the right time that can just throw that one little piece on, you're done. You're golden. It's one piece of tape all the way, top to bottom, continuous.
That's
no
stick-on
problem.
membrane.
This one is not.
Yeah,
They
this is our Intello. This is our.
It could be though. Nope.
Yeah, I'm actually recommending, which we'll show you an image of, which I think, we don't have an updated image on this, but essentially I'm recommending people use the Soltex Adhero. This is great because it could follow tricky geometries. It sticks to the substrate. It gaskets when you penetrate through it. So this will seal at the fastener face as well. But what's great about it is instead of doing this, which for the longest time, this is what we did do, is go back to the other one, Johnny, is put a floppy piece of membrane over the top of the floor plate. Could you go back to that one? So usually we would have someone take Mento or a house wrap, flop it over the top plate, set their wall, it's on the outside, bring it back up to the top of the floor, and then when you set your floor back onto that, it's a simple tape connection of membrane waiting for you at the base of wall. That works, but it's annoying because, as you guys know, with working with Tyvek, things flopping in the wind sucks, and it's annoying to deal with. So I'm recommending people actually use Adhero and tape the top plate, do the whole perimeter. Take some of this into a strip. This is a 5-foot tall roll. Cut it down into.
Do you make that in a narrow wall?
We have 12-inch tapes as well. We do not make a more narrow roll of the Adhero, but because if it's being used as a house wrap, I'll give you some tips to make it as a tape so you can use it in more locations. So this is great being used on the top of the wall because you guys can walk on it. It's not going to slide anywhere. It's on the substrate. It gaskets, and they set their floor. They'll run a piece. Johnny, could you go back to the floor to floor? Yeah. So with the fully adhered, you'd encapsulate the top of wall. Great. You set your neck floor, a peel and stick, an L down to connect to this face of tape. Now you've transitioned from this floor up to that one. set your floor, your next wall, and then just tape it off. So the peel and stick makes this type of transition a lot easier because it's not hanging out. You stick it to the substrate, move through your process. When you get to the next floor, stick it to the substrate, continue moving. It's just an in-between step. It's not going to stop anything you're already doing. That's kind of the goal. If we want to weasel in to where you're already doing things, but just so you don't have to redo them later on. And this kind of helps with that, to the effect that if you are able to pre-sequence around the floor like this, you can avoid the headache of this. And this is where the Viscon is very helpful. If you forgot to pre-sequence and do the wrap around the floor, getting up in here and taping around these, if you didn't happen to place this first, would suck. So instead, that's where Viscon comes in handy. Just spray the pocket on all three sides, and then anywhere you tape to the Viscon with the Intello or any of our tapes, you've effectively transitioned, because this is an airtight material, the Viscon's airtight, so as long as they're joined, you've made one big airtight material. Same factor kind of builds from the ground up as you stack more layers. And we've got some better documentation of this on our website, which I can show you guys as well. But let's do the pre-sequencing example. So I want everyone to try to get some of this tape pressed into here to that wall as best as possible, as if you forgot to put the membrane there and now you have to afterwards. And you'll see how annoying it is. That's kind of the goal we're trying to get
You're
across.
supposed to tell them it's annoying first. It's got to be a surprise.
Don't mess up. There you go, Mario. Well, you got to be able to do it the other way though, in practice, really, because you need to be able to, so it needs to be that long, longer than your bachelor.
So I just want to show you guys really quickly just a better image of what we're trying to avoid, essentially. This is the detailing that works very well. Lots of labor, lots of taping. A lot easier if you planned around it. So this just kind of is just showing the example of beam pockets of what you can do, and then we're going to show you what you can do instead. So if the home's already built and you got to transition between floors, this is showing Viscon sprayed in the rim joist area. This is Intello. What's not shown is they're going to run more Viscon on this seam here, and then they'll run a piece of tape, just a straight piece of tape across that board. And now, as long as they're touching the Viscon, they've transitioned to the underside of that subfloor, and then on the top side, they're taping the seams, and now they've made their subfloor their air barrier. Again, this is labor intensive. In an ideal scenario, we're doing this instead, which is where we're wrapping top plates with Adhero. So when you set your rim board or your rim joist on it, you can see here, they're all encapsulated. Technical difficulties. But what this is showing is an exterior house wrap taped to this top plate, and they're transitioning to an interior ceiling air barrier. So now anywhere their interior ceiling hits this perimeter on the inside, they've now jumped to the outside of the wall and to their exterior. So it's an effective way to transition through some of these areas, and it's as simple as just telling your guys on site, stick this on all top plates. And if they happen to do the interior partitions, whatever, it's a lot cheaper than remediating afterwards and tell them to do everything. So this is a great way to do it. And then we actually show here, which I'll quickly, this is a good enough image, but piece of tape, floor, and then you're just taping to this band that's hanging out on the bottom of your floor, kicking out to the interior. So it makes these transitions much simpler if you can just pre-plan. That's really all it is. It's not a big step in the process to have them tape the top plates. It's a bigger step to have them go and do this. So that's what we're trying to kind of hammer home with some of these things. And I can be helpful with these processes because I work with builders and architects and get to look at the plans with you guys and help point out some areas where we'll want to start thinking about these things. Another area that I commonly touch on is exterior, like exposed rafter tails. I'll quickly show you this. Transition. Applied rafter tails. So at the exterior, that same interior rim joist condition exists out the outside with your exposed rafter tails. Again, we want to avoid doing this. This is annoying. This works, but this is annoying. this is where Viscon comes in handy, and or pre-planning. So obviously not all projects are able to monopoly frame with the different overhangs and things that we want, but this is showing a simplest condition where you could run roof to wall and then apply everything afterwards. So what we're showing actually is a few methods other people have done in the past to get their roof venting in line with their rafter tails. So these were notched boards where they actually on CAD created a notch in the boards as you see here, which they cut for all of them using a double-sided tape we have because they're using a mechanically fastened roof underlayment. This will self-seal as they drill through. But what we're trying to get across here is they've got their overhangs and continuous venting. And then the other way, which I like better because it doesn't impede process as much, is doing a ledger to the wall. So you could conceal things in here like, if you guys are doing rolling shutters and things like that, they can be concealed in this area. This is thermally broken from the building. You don't have to worry about a thermal bridge penetrating through with that rafter tail. And as you see, their strapping on their walls, which is their vented rain screen, is following pitch with their roof as well. So they're not impeding airflow from roof to wall on this detail. But just to get your gears turning with some of these connections that you usually would just gloss over, that these are air leaks and areas where you can remediate and kind of pre-plan to get some of them kind of preset. So again, more pre-sequencing. They've placed this material before they set their roof on it because they know they're going to be having to get to that exterior wall. So just making their lives a bit easier is all. And this is showing that surface cavity. But I want to let you guys do more of the penetrating. So did everyone or start to get their tape stuck in there? Yes.
How are we going to get it out of there?
Yeah, we'll figure that one out. That's our problem.
I just like doing the corner ones. No. I think it's fun.
Yeah, so obviously you guys
There we
can
go.
get into those corners. That's why this tool
You get it
exists.
nice and
But
snapped in
it'd be
there
a lot
so it
easier
does.
when you have, the amount of studs you guys will have on a project is a lot more than one. If this took you 3 minutes, exponentially, grow that out till you get to the size of some of these projects you guys work on. So very helpful to have in mind to reinforce. And then the last thing I want to show you guys is the beam and then the pipe, and then we'll do the window taping, which is really interesting, and we'll kind of discuss a bit more as we're seeing more high performance clip applied windows or flangeless windows. So next, let's do the beam penetration. Johnny, do you have that good kind of tip for rounding the corner for that, the outside corner?
Oh, yeah, no, I mean, it's kind of the thing that you had brought up earlier about watching the corners. So if we're imagining this as one of the rafters that he was just showing, you obviously want to start at the bottom to properly shiplap if this is on the exterior, but we're basically, as you saw, it's very easy to get into tight corners. This is, this angle is difficult to get to, but if you have this, you can slip it right in there. And then the real only trick is
the way you cut it.
We're not cutting all the way to the corner of the wood. We're cutting just away from it, so that when we fold these over, we're guaranteeing that
we can pass that around.
This little edge here has like this nice little fold over here that we can then tape around.
Yeah, so it'll make contact with it, and then you avoid that pinhole you're talking about at the corner.
Right. Yeah.
It bleeds into the straight line instead of at the actual 90.
And so again, got this piece here. Now, when I stick this on one of the side pieces, oops, I messed
And that's
that
why
up
the
real
Pro-Fill is
good.
helpful.
I messed that up real good, but that's okay. We're gonna, I'm just gonna show you this edge here, but when I get it nice and over the last piece, then we're guaranteeing that we're covering up that corner entirely.
Yeah, so it'll be a
And
45-degree cut, but not directly from the corner. You'll step it off an inch so that that
Not an
corner
inch,
itself, or
just a hair,
not even an inch.
but that way you get nice, drainage coming down in terms of water on the outside.
All right, now you guys try.
Right.
And I can walk around and give some help where needed.
See, I need practice. I've been too busy making those blog posts, so I haven't been doing it myself. Would you, you want to try? You could just go right over on top of this one.
Yeah.
Nice.
Beautiful. That's great. So you can see it works, but it takes some time, especially tedious when you have 50 of these in a row. Again, that's where the Viscon, the liquid applied, helps because it can fill gaps. It can go on all the substrates. Achieves the same goal, but doing it in a much easier process. And then even better is if you just put the membrane there first, and you don't have to worry about it. So it looks great.
It's like stick on root membrane.
Oh yeah.
Yeah, nice. It kind of helps that these are rounded bed.
Yeah, this one has a lot of weight.
Yeah.
So it's a little more.
You
little,
can tell.
little
You
more
can tell.
That
you,
number 3
ex-
number.
ex-
I mean,
exactly.
look how much that's curved. You can
Yeah,
tell
that's
this
crazy.
is why this was the scrap wood.
I would hope you wouldn't see this on a job site.
Yeah, right.
that would be a bigger issue. Yep. Call that one out. All right, great. So we all did the beam. That's awesome. Yeah, so the important thing about the beam penetration is where you make the cut. So where you have the weep hole, I guess you can call it, of where water might find its easiest path in. So you're trying to avoid that by having sufficient overlaps, by not cutting into the corner, but cutting up a bit from it. So that makes it very helpful. The next thing we'll do is the pipe, and then we'll do the window, and then we'll have some questions. So for the pipe, what I want to show you guys is currently how we're going to have you guys do it. This one. I think my computer died.
Well, we can.
If you want to
just go
discuss the
over it,
hula
but
skirt,
basically,
yeah.
we have a couple different methods, but one we call the hula skirt, and that's pretty obvious. You just cut a bunch of little pieces, and you go around, and it makes a nice little hula all around there. Which, again, take a little bit of time, but that's method number one. If you're in a pinch, or if you just have the tape. And then basically you can only cover so much curve with it at a time. So you go around one piece after the other, overlapping on the exterior, if it's the exterior, shiplapping also,
So
ensuring.
your lap is how?
Just a quarter of an inch.
Yeah, quarter of an
fine.
inch. For all of our tapes, this is a good rule of thumb to go off of. This width is really about as much we say to create an air seal. Anything less than this, it's debatable if it's stuck enough. But if this is fully adhered this width, that's airtight and that's watertight.
So we're going all the way around that. So that's easy. Doesn't require any extra equipment at all. And you'll get around it. The other option is again the gasket. So just this one is actually a little too small. You are too big. Usually we might have a smaller one. I want one that's
I
the
think we
right
do.
size for that one.
And I could get a list together to send out to everybody here of all of the things we discussed, the blog post that I showed you guys. This is a very helpful one. It's called How to Seal Air Barrier Penetrations. So kind of what we're doing. It's a catalog. Kind of shows all of what we offer, different sizes, how to apply them. These are quick links right to the page.
This gets the point across, but basically,
yeah,
what we often usually hear is, you sent me the wrong size. These are too small, but it's because you want them to hold tight. So this is why I know it's not the right size for this particular one. We would want one size smaller, but basically you pop it on, 4 pieces of flat tape, you're done. So those are your your 2 different methods for circular.
Everyone give it a go. Do a hula skirt.
Here's a couple more pieces.
And you'll quickly see with the hula skirt, it's harder to get nice lines and overlaps without bulging seams and things like that. It doesn't look as nice, and ultimately there's a higher risk that it doesn't perform as well, just because there's more application needed. You have to know what you're doing for all of the strips. So.
I thought we had one the right size.
It might have been. No, I guess not.
I guess not. Yeah, it would have been the.
It would have been the other the Roflex
5.
20. We didn't have a 20. We only had a 30.
We're losing one on man.
I'm just glad it's not blowing 20 miles an hour. That's how I usually
That's
Yeah, exactly.
Yeah, like, oh, this is easy inside. This is a cake. That's stuck from your hair.
Peach mineral water.
and I want to say, other good uses for this tape, which I have used plenty of it for, is, funny enough, clothing repairs. I mean, it's a fabric-based tape that sticks very well to your clothing. Will go through the wash. I've fixed motorcycle pants with this. I have fixed a car seat with this. This stuff is great. So good to use really everywhere. Oh, you just wait. I was on a job site where they got wind that they stick to clothing, and they were all patting each other on the back. So I got to the site, and they all have patches all over their back because they're playing jokes on each other. Like, that's a great use of the material. The guys had a
That's like $50.
correct. Yeah, exactly. I see that. I'm like, you are burning it for the wrong thing. Yeah, the foreman wasn't too happy with that one. And it's part of your clothing then, so that's not coming off their sweatshirt.
Where's your distribution out of? How long does it take to get this?
Yeah, UPS ground standard routes 3 to 5 days. To this area, probably 3 days. Our warehouse is in Denver Central. It's between the corner of 6th Ave and I-25, so like in the middle of Denver. Yeah, they're very quick.
So is it like a place?
You could do will call or orders. Yeah, you can order for pickup, drive in, pick up what you need, a pallet or more, whatever it is. And we do have same-day pickups if you place the order before 11 a.m. Anything after that's next day, and then shipping is usually 24 hours it goes out. But yeah, UPS ground, very quick, and anything larger than that, it's freight. But yeah, you guys are lucky that you're within driving distance at least to the warehouse.
Is the thing where the intent is to get somebody here to stock it, or you just always be essentially
Kind of in Denver for the most part. I have attempted in the past, but it requires projects, obviously.
I mean, if you know a good lumber yard that you would be interested in having.
I just don't know. I don't know a good lumber yard. No. If you bring one.
Yeah, and I am available to come onto site to do trainings for your teams of installers, whether they're doing house wrap, interiors, windows. I talk through it all, to show up on site, help do blower doors, and kind of support your projects through the process. Even from planning, meet with the architects, figure out what their goals are, translate that to the builders and the people installing it, make sure everyone's on the same page to pull this stuff off. Because we know it's a lot of detailing. It's different. It's not easy, but it's also not very hard if you just quickly get a chat through how to do it. None of this stuff is more difficult than what you already do on a day-to-day. It's just slightly different, or if anything, having you slow down the process a bit more. That's all. So we all got our pipe done, and this is just reinforcing why we have these nice gaskets. It makes it a lot easier. They're available in multi-packs, 15, 20, 30 packs type of deal. So just very good option to get a stack of if you're unsure how many you need and work through them. But also why we recommend, I mean, in general, there's nothing special about this. Obviously, it's special because we made the hole, but you could buy EPDM and put a hole in it yourself. It'll do the same thing. And that's what we show here with the contractor that kind of did it themselves. They had a lot of pipes. We don't sell a gasket that big. That's okay. This is a scenario where we would encourage making your own. Makes it a lot easier. They sat someone down to stencil out and punch them out for a bit on site, save them some money. And then also this is just showing how Viscon, again, can be used as a flexible air seal with the main intent still with all of our penetrations to treat each penetration as an individual hole. For the reason being, if you took a bundle of wires, put them together, in the center of the wires, that's an air leak. Around the perimeter, you might be sealed, but that bundle, each wire is still touching itself. So you want to separate them where you can. And if you can't, Viscon the crap out of it and just put a lot of Viscon on it. And that's your kind of cover-all fix for most of these types of scenarios. But the last thing we're going to do, oh yeah.
Viscon just gets used with that.
No. Yes, I didn't note. We sell this in buckets and in sausage tubes. The buckets are only available for standard Viscon, and that can be painted on, sprayed on, rolled on. We have an airless sprayer guide of sprayers you can rent, like a Graco Highboy, like a pretty standard like latex sprayer can spray this type of stuff. And aside from that, the fibrous version is only available in sausages. So I'm typically seeing people get the sprayer because it can spray both versions, or just get a tube, cut some out in some cardboard and use it like you see here with like a putty knife or a paintbrush just to get it on. It's not picky. Yeah, and we also have a regular sausage gun and it for caulking lines. So great use to caulk a line out, take a putty knife and spread it out so you get it covered where you want it. The real thing about this material is that it's not picky about how it's applied. It just has to get on the wall or get on the surface, essentially. There is a wet mill thickness guide for if you're spraying it to get a uniform thickness. We are seeing this being used for historic masonry buildings on the interior side of brick walls, where you can't air seal that realistically very well. This is your cover-all solution. It's not going to trap moisture in the brick wall. So for retrofits, this is a fantastic option to get a kind of more of a proactive air seal before you do your Intello or your whatever your interior air barrier may be. Very effective. This was actually kind of more engineered for those types of substrates and has since expanded into everything. But it found its footing in New York doing brownstones. So the last thing we will discuss, which is kind of going to be our most in-depth side of things, is the window. We have a very comprehensive window installation blog series.
Windows are complicated.
Windows are complicated. So if you just type window, if you click on any of the portions, you could get to the start of it, but you see it is an 8-part series that starts with how to prep your rough openings, moving all into different conditions of installation if you're doing masonry or kind of the varying conditions you might expect. So what we want to really highlight here is not only window taping, but taping to these newer style windows that we're now seeing more and more of, these clip-applied flangeless windows. We're seeing less nail fins, essentially, as we see more of these high-performance windows that are triple pane for these nicer homes. They're abandoning or straying away from these standard vinyl nail fin windows. So this is where you see some of these more clip-applied European frame, and this is where the install technique that we've coined the zero reveal taping technique. And we call it zero reveal because when you install the window into your rough opening, assuming you've got, like, for example, a built-out buck, you should see no tape on the face of the frame. The frame itself is exposed. Your finish is, your nice walnut frame is, not getting taped over. Your tape is actually happening on the outside, top, sides, and bottom of the frame. So your air seal and your vapor control is no longer going to be impeding your finish. So that's a lot of the issue with sealing windows is what can you conceal and how far can you get, and that's why a lot of people rely on backbarrage and caulks. The issue with those is that they dry and crack over time and need to be remediated every few years. These tapes are artificially aged to 100-year standards. They're supposed to be set and never removed, part of the home until the home, withers away, once the materials break down in 100+ years. But the idea,
It's kind of like you're creating a gasket for the window.
it's a better way to put it.
That's the way I think about it. So basically, the way that we've seen people do this most effectively is you got your window, it's on a couple of horses, and you go around with one piece. I gave you one piece that won't cover all of it, but if you imagine these are windows for a second now. Our corner that that comes together, not the one with the gap. Basically, all we're doing is as we're going around with our double-sided tape. So the little white strip on the outside is our double. This is our full adhesive side. We want that to go to the building. So this double side, that goes around the outside of your window. And then we're creating what we call a bunny ear, where we've gone beyond the corner and we've squished that together as we're going around. And that gives us enough room that we can actually, I would want a bigger one. This is for demonstration purposes, but big enough that we can make this flat against the building around it, right?
This is the outside.
Yes.
Yeah, so for both conditions, Johnny's right. If we were doing a flat install, flush install with the exterior, you'd want a face tape condition where it's still flush. That's where you got to leave yourself enough to do that reverse fold. The other condition that this supports is a built-out buck where, there's framing running out past it and the window's mid-set or inset. Then this just follows the exact line of the buck and it's sandwiched between on all sides.
But you have some options here. You could come out a little further, flop this up there or further. Depends on where this is in the wall.
So here's an image kind of showing what Johnny's talking about. But they're rounding the corner, taping it. And what's important to note is that there's taping all four sides, but they're not covering the weep holes. The window will still weep where it wants to weep. The intention of why we're still covering that bottom flange or that bottom seam, I guess you could say, is because we don't want to leave a weak point for cold air to come in through the bottom of the window. As you know, that's going to be your weakest point in the wall where you have your warm air on the inside and in the winter, your cold air on the outside. If you're letting that cold air through the bottom of your window frame for drainage, you're creating a condensation condition where your cold meets your warm in the center of your window rough opening. And that's why these older windows or existing windows rely on their weep holes for all their drying needs because they're creating moisture. They are. With leaving that bottom flange open, they're inviting condensation in. So they're relying on the weep holes to weep constantly because it's going to work, but we don't want to create a condition where you're even inviting that moisture in. So we seal on all four sides, but maintain the weep hole actually open. And I'll show you that image here with exterior window taping. But as you see, they're sealed off. They're still weeping. They're not creating a condition where they're inviting more moisture into the wall. So any moisture that is in that gap between the rough opening and the frame can dry through these tapes because the tapes are vapor permeable. There shouldn't be condensation in there. It should be moisture, just water vapor. So that should dry through the tape. And if for whatever reason it overloaded the tape and had to condense, you still have your weep holes. So it's a two-line of defense kind of outlook and not just relying on the weep holes for all your drying purposes. They're going to dry when it hits that critical threshold where it's physical water, but anything in vapor form should dry out through the tape before it even condenses. But that's kind of the intention. And additionally, I don't love the idea of leaving the bottom flange open because God forbid, your interior air seal failed. Now you have a continuous path for air to move from inside or outside to inside. So this is a double kind of barrier outlook where you're giving two air barriers or two lines of defense. Even though the exterior house wrap is airtight, we're calling it our weather barrier or our waterproofing layer. And then the inside, even though it's also watertight because the materials will do both, we're calling it our air barrier. So, you'll see with our materials, they check both boxes in both locations for most areas. Everything's going to be watertight and airtight. But on the plans, what you're physically calling them out as is important. Because you'll detail your air barrier very different from your house wrap if your house wrap is not your air barrier. So important to note.
So if you want to give this a try, I would pull off just a little bit of the white strip on the outside, start going around your edge, and as you get to the corner, kind of experiment with how big of a bunny ear you want to do at that corner. You can kind of play with it to start with and see, how much can I, undo after the fact, depending on the size of that. You could flare it out a little bit too.
And something I want to mention to this effect is, as you are, turning these corners outwards, you'll see some aesthetically, not as pleasing things like folds like this. I want to mention that does not matter. Aesthetically, it might look like a fold or a wrinkle, but as long as you're stuck to the substrate, it does not matter how much the material's waving. It's still continuous and sealed off. So,
but yeah, I think another thing I wanted to mention about it is just, this is another example of that kind of thing that you could have one person specialize in putting these on, and everybody else treats the window the same. It just goes in, it gets clipped in place. Nobody else has to pay attention to this thing. It can sit there as long as you want. It's good in the weather. You can tape them down out of the way. You could leave them hanging.
Yeah.
When you're ready to connect them, then you do. But then that gives you the flexibility of just leaving this there.
Correct.
As needed for as long as you need until you're ready to connect.
Yeah, it's creating a condition where you're pre-taping in a more controlled environment on a sawhorse or on a suction cut machine. I'm sure some of these sites you've been on have them for these heavy windows. But by being able to pre-tape in a controlled environment, not in the rough opening, balancing the window, you get a better connection to the frame. And then, but since this is pre-taped, the adhesive's covered on the backside. You just, like Johnny said, take some masking tape, pin it out of the way so you can handle the window, get it into the rough opening. And when it's in the rough opening, it's no longer putting your hands in there and sticking and pressing. This is already in place. Pull the adhesive and press it into place. It's the exact profile of the window. So this is easy to get a continuous and neat connection in these rough opening conditions where you have these heavier European windows that don't want to be taped in the rough opening because they're hard to move around. They're fragile. It's better to do the fine detailing in a more controlled environment. So sawhorses, suction cut machines. Obviously, we know that's not always feasible, but with the intention that this will make your life easier, essentially. Yeah. So let's do a corner. Let's see. And I want to mention, this is the same tape I talked about for your foundation or to concrete connection. The only difference is that this tape has a front release strip of adhesive. They're the same tapes. They can be used for windows. They can be used for walls, doors, foundation connections. This is kind of our coverall, all solution tape. And I want to mention, it is our strongest adhesive. That's why I can stick to concrete with no primer. So anywhere you stick this, just be very sure it's where you want it because it's permanent. We had a call about that today, actually. Someone's like, I stuck it on a frame I shouldn't have. I'm like, you're going to have a fun time unsticking it. And we do have a trick for getting the adhesive off if you do stick it in the wrong place. It's certainly not easy, but it does work. So. And don't forget to pressurize. Well, again, you got to think about what condition is that going in. Is that going in an extended buck? If so, then it's perfect because it's just going to follow, that 90 straight out. Versus if you have to turn it out to the face, maybe you need to give yourself a bit more. And we do have some techniques that, you could to make it fold easier because you see it's still joined up back here, and then tape over it. And any amount of holes you make in any of our membranes, that's fine. These tapes are just as airtight as the membrane. Stick it to it and you are air sealed. So with the question for like interior air barrier, with the fear of penetrating it. Doesn't
Oh,
matter.
I have to check
Cut it
my
up as much as you want.
sample.
Just tape up afterwards. So remediation's not a problem in that way, just with the intention that you'll have to stick over it again. That's really it.
Yeah, could use
But that
some
looks
more
great.
time, but
Yeah,
it's pretty good.
perfect.
Yeah.
That's impressive.
Awesome. Beautiful.
Wow.
Yeah, that looks nice.
Do you know when this is scheduled?
That's awesome. I like that. No, yeah, that's a clever cut. Exactly. And then if
Okay.
you wanted any other like belt and suspenders, when it's installed, you could just do a diagonal piece over it, and then you're good. But this maintains your frame untouched. So for running finishes, you have a lot more room to work with now. And you don't have a condition where you have tape running, waving past that fine line that you've got to cover. And that's where the Tescon Profil for the interior with those nice, neat 90s work very well, because that's where finishing matters that much more. When you have finite amount of room, you have your bucks, you can't keep building more drywall on top of that. You've got a certain amount of space to work with. So that's where having these split release backings for the triple make it very easy to kind of do some of these folds. And I usually I tell people, sit one guy down on site or whoever, have them make like 60 of these. Just sit down, cut strips, cut little notches, make a 90, throw them in a pile. So then when the windows are installed, you go around, stick them in all the corners, and then it's just straight lines of tape. That's a lot quicker than doing each corner. So delegating, air boss, these types of things to have in mind, it really helps the process. Let most people focus on their task, but have one person focus on some of these things. It'll save you guys in the long run for sure. Are there any questions about the window taping?
So the taping across the top, does that need to be shingled over the top, or for water seal?
So it depends what house wrap you're doing in process. I mean, yes and no. Best practice will say obviously shingle the top of it for shiplapping reasons, but this is enough adhesive of stick that no water droplet should be able to run behind this tape. Like we want a 1/4 inch minimum, like a pinky's width. But when you get into, a hand's, a palm's width, 3 to 4 inches, there's not enough water pressure to drive behind that tape. So you technically don't need to, but I would always say best practice, shiplap everything. Like that's, the fail-safe way that you're not going to possibly have a failure. So yeah, you could run this over or under. You just have to leave that flap, corner cut, ready to fold over. And that's where the Adhero is helpful as well, because this membrane does come in a 5 foot tall roll. I'm curious if any of these have it, where the top 10 inches is a different release strip, like all of our stuff. So it's not pulling one big sheet for the whole thing and it's sticking to itself. You'll pull that top 10 inches, get it plumb and level where you want it, stuck across the wall. And then once that top seam you're happy with it, pull the bottom. And as some guys walk in with the big press fix, we have a double wide one called the Press Fix XL that's like 12 inches wide. And to take 2 hands on it and just swipe down the wall like a big squeegee as someone's pulling the backer paper. And some key things to note about how we are different from the Blue Skins of the world, which I really want to highlight because this is important, is the actual construction of our membranes. There we go. So many of these house wraps on the market are going to be microporous membranes. Mostly, I think all of them are microporous membranes for the most part. These are the Segas, these are the Blue Skins, these are the Tyvek, the Kingspans. Really, every house wrap system relies on these microporous membranes, and that's on a microscopic level, taking a sheet of plastic or poly and stretching it. And what they're doing is creating micro perforations, as you see here, with the intention that bulk water, a water droplet, will have enough surface tension to run over these small holes, but water vapor can push through them. That's good in theory. It does work pretty well. The area where it fails is on roofs. You cannot have microporous membranes on roofs. If you think about it, it's a screen door and a water droplet. If you put it at pitch, that water droplet will eventually find a hole to fall into. That's why you don't see Tyvek selling the same Tyvek for the wall as for the roof. And that's where we differ. All of our membranes are monolithic in their construction. They dry through diffusion, so more active water transport rather than relying on vapor pressure to push vapor through the material. And this is why our materials, like Adhero, can be used for walls and roofs as an underlayment. So one material can cover everything. This can go down to 312. It can go down to 112 with a primer and additional tape. But 312, just this alone, nothing else, can be your underlayment and your house wrap. It gives you 6 months of protection for your walls and 4 months for your roofs. And we have a different version called Adhero 1000, which is going to be for walls only. And that'll give you 3 months of UV protection for your walls. And we just don't recommend it for roofs, not because it can't be placed there, just because we're very familiar with how roofing gets installed in the US, and it's just a bit rougher than they do abroad. People are walking on it more. This is thinner. It's more likely to tear. This is a lot thicker, less likely to tear. So you can walk on this all day without having a peace of mind. This we'd be a bit more concerned about, so that's why we split them up. But in Germany, they are using this stuff, roof and wall, for all of the same things we sell. We just are aware of install practice and know that things, have thresholds in that way. So that's a great difference to show you guys. And the last thing on this topic is, I'll quickly pull it up here. Johnny, do you have anything to add?
No, I think we're
Yeah.
about ready to.
Wrap up. This is
Wrap
the
up,
last thing
so.
I wanted to show you guys, and then do questions, and that's it. Here we go. This is a quick 60-second video, but it really hammers home the actual visceral difference between our materials and kind of some of the more commonly used materials on the market. I wonder if sound will come out. Well, I'll speak over it so you guys can see what's going on. So what we're showing here is our CEO florist out of his home in upstate New York. He's showing that it's winter. It's very dry outside, around 39% relative humidity, so pretty dry in the winter. And they're showing the condition of a heated garage, or it's heated on the backside of this, and they're comparing Tyvek, our Mento 1000, and then Siga's MyVest membrane. And we want to show on the backside of this membrane the wetting that's occurring or the dryness of each. So as our CEO goes to the backside, florist goes in. He's got a paper towel in his hand, and he's going to wipe the backside of each of these membranes. And this is where active vapor transport is very important. And what you're not seeing, you visibly don't see this on a project. But right there, you've got our Mento. He wipes it down. It's dry on the back. Now we've got Tyvek. Wipes it down. You can see it's wet. And then with the Siga, he wipes that down, and it's sopping wet. So this is the result of active vapor drying of monolithic materials versus microporous. There was not enough positive pressure of vapor drive to push that moisture through the Tyvek and through the Siga, but we don't require a vapor drive, a vapor pressure in that way. The moisture was present, and it was passed through the membrane to the other side. This is the condensation layer that you're not seeing on your homes, but on the face of your OSB, behind your house wrap. That's where that moisture is sitting, essentially. So I don't know what this is, but that is all done.
That's one of your videos.
It might be. But yeah, I think that's a good little overview. I know we covered a lot. Please let me know if you have any questions, and I'd be happy to meet with each of you individually later on to discuss your projects if you have any. Thank you.
Well, thanks for coming, everybody.
Yeah, I
and
really
thanks
appreciate
for being
it.
part of this. This is our first experiment with
This is the
hands-on.
inaugural training with these materials. So
Good idea.
did you appreciate not just having us talk the whole time and having some hands-on?
yeah, and feel free to offer feedback if there's anything that you think you'd want to see of a condition that you see on site that maybe wasn't exhibited here to hone in on. Maybe even conditions you're struggling with for air sealing that you have questions on. We could speak to it a bit better. Thank you.
Well, thank you guys so much.
No problem.
Yeah.
So your membranes on a wall, there'd be no concerns with putting it on before we stand the wall, we sheet the wall.
Yeah, we work with I think at this point 15 or 20 prefab manufacturers that pre-wrap our walls in a factory, ship them to site flat, and then crane them up, stand them up under a tarp one by one. Be Public is one of them. They're out of New Mexico, and they use our entire suite of materials for the outside and inside of their panels. And they have some projects up and around, I think, this area.
Very close to here.
Yeah, very close to here. But yeah, we do. So fine, you do whichever process you'd like. The one thing to keep in mind is that if you are leaving these flat, they are permeable materials. So if there is standing water on them on a flat surface and the sun's out all day and that turns into vapor, it can diffuse through the membrane. Exactly. But again, at that point, it won't matter at that point. Exactly. So you can stand it up and it'd be fine in that way. But yeah, we've got a bit of everything. I know there's a lot. So thank you guys.
Energy Smart Colorado is going to be connecting folks in clean energy careers with those students in our local areas. They're looking for about 12 applicants over all their regions, so I think 1 to 2 from this county. I can share a link with anybody who's interested. It's just kind of going out and talking to students about things like a career in air sealing or weatherization or heat pump installations, anything like that. You can expect to spend anywhere from 10 to 20 hours on the actual work, and then with the meetings with clean energy careers, probably about 32 hours over the course of the fall semester. So it would be this fall. But yeah, if anybody is interested, it's about a $2,000 stipend from Excel, and you do have to be a registered trade partner with Excel.